So yeah, let's make it happen. So let's talk about conditionals and shapes. And then I do also need to remember to give you a programming assignment today as well. So don't let you leave before giving you a new programming assignment. So yeah, we're going to learn how to make shapes as well. We'll draw pretty pictures in an easier way. All right, so let's see here. I would like to teach you how to do conditionals in Python, which is going to be exactly what you expect. You remember the if-then-else block from Scratch, right? That's what we want to be able to do. So let me do my best. Kind of looks like an E, I guess. But this was your if-then-else block, right? It was like if this condition, this pointy thing is true, right? Do the stuff here, like then do that, otherwise, like else do this, okay? So like if this stuff is true, if this condition is true, then do this thing, that's like the then part. And then if it's not true, if it's false, otherwise, else, we're gonna do the else stuff. So otherwise do this stuff. Otherwise, all right? And so somehow we're gonna translate that into Python. Okay, that's the goal. How do we make it happen? Like you can't really can't use your mouse to hook things into other things in Scratch. This is going to be text-based, and the key is going to be indentation. We're going to indent when it's it's the then part, when it's the else part. Okay. So yeah, to get there though, we need to talk about how to make pointy things in Python. So it's a new type of stuff, right? It's called the bool type. Very scary. So you know the ints, right? You know the int type. What does that hold? It holds whole numbers. Ints are whole numbers. 0, 42 is an int. Negative 42 is an int. And store big whole numbers, and then float is the type of things that have numbers with decimal places, right? And stir is the type of quoted strings of whatever you want. Bool is a brand new type, and it's a very small cloud. It has 2 things in it. So the bool type has only 2 things in it: true and false, and they're capital T and capital F if you're coming from another programming language. So those are the only 2 things you can put in the bool type. That's what we need, right, to ask questions. Like the yes answer is true and the no answer is false. So just like in Scratch, we can use that idea of true or falsiness to control how our program runs, right? So maybe get a number from the user. We know how to do that now, shove it into a variable. And we can ask about the number, right? We can be like, hey, was the number in the n variable, was it less than 7 or something? Question mark. We'll be able to ask that in Python, and then do one thing if the answer is yes or true, and do another thing if the answer is no or false. All right, so that's the goal. That's what we'd like to do today. All right, and that will control the rest of the program. Do one thing if it's true. If the condition is true, do a different thing if it's false. And so that allows us to branch, all right, branch off and do one thing or another with the help of something else. Okay, so that's going to be the goal. Let me show that to you. So we'll just do it in the REPL to start. So here is, let's open up idle. Hopefully it's still installed on the machines in front of you. Go install Python again if it's not, sorry. But yeah, we'll talk about bools. All right, I'll make a brand new type, I guess. Let's do, let's go out of the REPL. I'll make a new file for the day, why not? This is lecture number 18. So let me save this file in a lecture 18 folder. In a lecture 18 folder on my desktop. I'll call it bools.py. Alright, so now we can go back to where we were. The bool type, very small little cloud, has true and false in it, and those are things of type bool. So I can say, let's print out the type of true, because true is a bool, right? And let's just prove to ourselves, yeah, that's right, it's a bool. Yay, there it is, it says bool. Same with false, that's their type, just like the type of a 42 is int, so that's that. And you could, just like any other thing, you can shove a Boolean value into a variable. You can say, hey, b equals true. Okay? B equals true, if I can spell true. And that will make a variable called b that holds a Boolean value, true. Isn't that cool? So you can do that. You can say b equals true, and then you can print B, use it, save it for later, less typing, I guess. And if I run that with F5, there it is. So it's just another thing you can put into a variable, and it's also something that you can use to control stuff. So you can, like this idea, right? What does this diagram mean? It's like, hey, you can check, right? You can produce booleans by asking questions in Python. Like there's a way to ask, hey, is n less than 7? And if the answer is yes, remember that means true. That's going to give back true once I show you how. And then if this is not true, it'll give back false, right? So what's another question about n that's not true right now? Maybe like, is n less than 3, question mark? And that answer is no, right? So Python, once we learn how to ask that question, it will give back false to mean no, all right? So let's watch that happen. Let me show it to you. You can actually just tell Python, hey, n less than 7. Watch. And it will do the right thing. You can say, hey, let's print the results of asking is 3 less than 2. You can just immediately say that. And that will be, like, Python will see this. It's like, okay, you wanted to do a comparison, a less than comparison. Let me go off and figure out the answer. And then 3 is definitely not less than 2, right? So the answer is no, so false. Do you see that? It's printing false. It's computing and then printing false. Isn't that glorious? Does that make sense? So like that, you have these kinds of operations at your fingertips. If you had an n variable, you can just be like, n less than 7. Just say n less than 7, and you can print out that answer. It'll tell you yes or no, false or true. All right? That's pretty nice. So let's see here. That is called a Boolean expression, by the way. All right, so it's just some big long string of code that eventually produces true or false. That's what a Boolean expression means. Any piece of code that results in true or false. So this bad boy was a Boolean expression. It's not true or false. I didn't type actually true or actually false, but it gets resulted in false in this case. Right? That's what it means to be a Boolean expression. And you could do these kinds of comparisons, right? Greater than exists, less than exists. You didn't have to just spell out the numbers. You could have had variables, right? If x held, I don't know, 10 and y held 5, you could ask, hey, Python, is x greater than y? And it will go and figure that out for you and give back true in this case. Isn't that nice? So you can do that. What else? You can't, it's really hard to type this, right, for less than equal to and greater than or equal to. So instead of those, we're going to do it like this. We're going to just say less than and then an equal to sign, or greater than and then an equal to sign. So let me just do that really quick in the REPL for you. You don't have to print it, but like here, let me just type it at the bottom here. Like, hey, is 2 less than 3? Is 3 greater than 2? False. Or sorry, true. Is 3 greater than 2? True. Is, I don't know, is 5 greater than 10? False. Is 5 less than or equal to 5? Yes, because it's equal to. Is 5 strictly less than 5? No, it's false. So you have all those operations still. All right, that's how you get at them. And then you can check for equality with a double equals. Okay, so a double equals checks for equality, and it will give back whether or not something was equal to something else. So here's that, like, hey, Python, is 2 equal to 2? True. Is 2 equal to 3? No, it's not, so false. It's got to be double, though. Okay, double equals, because you know that we're already using a single equals for something else, right? That's this idea. That's not a check. It's a set, a variable thing. So just to make it non-ambiguous, double equals means check for equality and give back yes or no, true or false. All right? So that's checking for equality. This exclamation point equals checks for disequality. Hey, are two things not equal? It's like you read this exclamation point as not. And it's like the Python way of writing that, essentially, because that's hard to type. It's like checks for whether or not two things are not equal. So 2 is not equal to 3, right? 2 equal to 3 is false. So 2 not equal to 3, that check is true. Does that make sense? It's a little backwards. Hey, is 2 not equal to 2? No, false. It is equal. So that's kind of how you think about it. And once you have like some Boolean values, you have true or false, you can of course combine them using our combinators that we know and love, like and, or, and not. Remember those, right? So then you can start checking things like this, like maybe make a program for like an amusement park ride, and like check that, hey, is the person who is about to ride the ride, is their age greater than 12? That's one check, right? And is their height also like greater than or equal to 48 inches or whatever? And you can combine those with like an and. to produce a bigger final true or false value based on both of these conditions at once. You remember and? That's this one. It's like it's only true if they're both true. So x ANDed with y, that's the fancy symbol for it. So here are all the options: true, 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 false, false, true, false, false. X ANDed with y is only true if they're both true. So like you want both of these things to be true at once, and only then, if it gives back true, can the child go on the ride or something. Okay, so that combines two bools into another one. All right, so let's put that in the code that I'm giving to you. Let's be like, say print, hey, is 3 equal to 3, right? Print, hey, is 3 not equal to 3? So the first one's true, the second one's false. And there it is. And then you can like combine things using your and or not. So like if B is true right now, B is holding true, let's print out the value of not B. Do the not operation on B, which will flip it from true to false. So that's why we'll see false at the end there, all right? So yeah, I'm running it with the run module, but I'm just typing F5 to do it quickly, all right? Are there any questions about any of that? So that's like stuff from scratch that we can now do in Python. Pretty neat. So there's that, and yeah, let's see if we can extrapolate these ideas. I have a question for you now. So continue to do attendance. Make sure to do that, and I'll stop it after this. But I have a by-clicker question for us for once. So please get into peer instruction groups. I'll give you a few minutes to help each other out. But here is my goal for you. Let's say that we get a number x from the user. We're not sure what it is yet. And we shove it into a variable called x. All right? Which of these Boolean expressions produces true only when x is one of these blue values? It's between 4 and 8, and it's between like 13 through 15. Does that make sense? I want you to come up with like one of these is the answer. Which of these is going to give true back only when x is one of these blue values? Does the question make sense? See if you can figure it out without typing it into Python. That's my hint for you. But like one of those is the right answer. See if you can get it. Question first. No, you have to spell it out in Python. Yeah, good question. Technically, you can spell it out in C++ if you wanted to. Yeah, it's a little weird. Yeah. That's easier for the people who are learning it, I would say. So that's maybe why Python does it. Yeah, which of these is going to be the answer? See if you can pick out. With the rest of these, like pick out too many or too few. That's the problem. Yeah, for any other number than the blue numbers, it should give back false. So only if it's a blue number should it give back true. False for any other number. If x was 16, it should give back false. If it was 15, it should be true. Oh, I'm sorry. I got carried away. Or maybe I misclicked it, but there you go. A lot of people. Data scientists, machine learning people. There's a lot of people that have made libraries for Python. You can write games in Python. Some people have done that. A lot of websites, the back end of websites is written in Python. Stuff that like hooks into databases and stuff like that. But yeah, the engineers they like to use MATLAB at the start at least, but if you're a computer engineer, high level plus English, looks like English, you'll usually be using like C or C++ if you're an engineer. Sometimes you make a Python library that calls like your low level C code. So Python is good. C or C and or C++. the low-level devices that you program. But it all depends. It depends on the kind of engineer too, for sure. Oh, yeah. Was that enough time for us? Did our leaders that we elected get our answer in by now? All right. Let's see. Drum roll. Okay, nice. Somebody got it in at the end there. I get what we're thinking too. Good. Good. I think that's going to be the answer. Of course it was accidental. And then here I'll stop attendance too. So good. I think we got it. Is this not working? There it goes. So thank you for that. And let's talk about why the other ones don't work. I think D is going to be the answer. Yeah, D is going to be the answer. Let's talk about the other ones. So, all right. Why does this one not work? Can anybody tell me actually why A is A the problem? It's not going to do it right for some numbers.
Because it includes 9 through 12.
Very good. Yeah, do you see how, like, if the number was 9, it's, 9 is greater than or equal to 4, that's true. And it's less than or equal to 15, that's still true. So the and of them is true. Good. So that's not good. It includes too many numbers. So, like, it would go from here all the way to there. It would take too many. So that one can't be an answer. And then this one, I'll try to draw out why that's the problem. So it's giving back true only if x is greater than 4 and less than 8. So it's strictly greater. Strictly greater than 4 and strictly less than 8. Or strictly greater than 13, strictly less than 15. You see the problem? Strict less than and greater than is picking out the edges, or it's forgetting to pick out the edges. Okay, so that's why that one's wrong. And then C is almost there. It's greater than or equal to 4 and less than 8. So it just skips that one, right? Or it's greater than 12 and less than 16. So that's actually going to work for this part. But we're still missing 8. See that? So the last one is finally going to get it right. It's strictly greater than 3, so from 4 onwards, and we're cutting it from the other way. It's less than or equal to 8, so we're doing that. Or it is greater than or equal to 13 and strictly less than 16, so not including 16 downwards. Right? So is that going to make sense how I'm reading that and thinking about it? Maybe that's what you guys did. But good. Yeah, that's going to be the idea. And once you have your complicated expression, you can ask Python to do one thing or another depending on whether it's true or false. So that's going to be called not an if-else block. If-then-else block. It's going to be called an if statement in Python. Right? And that's going to test your condition and run something if it's true. All right. And I want to show you if-else next. So we're just going to do something only if it's true, nothing if it's false right now. So this is what an if statement in Python looks like. You say if, and then you give your condition, your big long condition, whatever it is, however big it needs to be. And then you give a colon, and then you hit enter and you tab over. It should automatically tab over in idle for you, but like you have to indent. You have to indent, and everything that's indented is like the stuff that you want to run if it's true. All right, so all of the indented code gets run if your condition is true. Code to execute when cond is true. So you have as many lines as you want to run, only when it's true. And then you unindent once you're done saying what you want to have happen, only when it's true. It'll just skip over it, all this code, if it's false. And then you unindent, and like now you're back to regular straight lines of code, right? Regular code down here. And because this is outside of the if, it'll always be run, like every other piece of code we've written so far. Always executed. Okay, so that's what it's going to look like. And just like the second it's done, if it is true, it'll run all this stuff. That's called the body of the if statement, by the way. And then you unindent and you're back down to here, and it will just continue down on, right? So after it's done, or if the condition was false, it'll skip over all this stuff. It'll always come down to here. Okay, so let me show that as an example. I think. Here, make a new program. I'll call it conditionals.py. I don't need that one, but this is way too large. There we go. So let's make a variable. It's like x equals 15. And then I'll do something if x is greater than 10, I want to do something, let's say. So I hit a colon and it automatically indents for me when I press enter. And so like all this code that I put right here is going to run only if x is greater than 10, and it is right now. So it will run for me, okay? So let's print something. Let's shout out to the world. X is greater than 10. Exclamation point. And you can do stuff. You can do it. More lines still, like x equals x plus 1. I don't know. Print the new value of x. I'm not sure. And then once you're done with all the things you want to have only happen when x is greater than 10, when your condition is true, you'll unindent, get back down to here. Now this is just code that will always run. This line always gets executed. And then you can just like print, do other things. Print 2 plus 2, print the new value of x, I don't know. But can you imagine what this is going to print right now? Right? Because x is greater than 10, it will run all this code. It's called the body of the if statement. Will get run. And so we're doing that. We're messing with x, making it 16, then printing that 16. And then we're done with the whole thing. Then we're done with the whole if at that point, and we go down to the rest of the code, the unindented stuff. Always gets executed forward, blah, blah, blah. If, though, the x was not greater than 10, if it was like 7 or something, then if I run this code now, this is false, right? 7 is not greater than 10. So it will skip out on all of this. Skip out and like, all right, then it's done. Like it either ran it or didn't run it, and it didn't run it this time. And then it just goes down to the rest of this code, which is always going to get run. All right, so you see the difference. Any questions about that? So yeah, that's how that one's going to work. Sometimes, though, we don't just want to do something if something's true and like skip it if it's false. We want to do one thing if it's true and a completely different thing if it's false. That's called an if-else statement. Okay, and that will let us do this kind of idea. Like, all right, have our condition check. We'll think about it as a pointy thing, like we're in Scratch again. And if that condition is true, do one thing, do all the true stuff. And then if it's false, we'll do something else, do all the false stuff. And then once you're done doing one or the other, again, you can like unindent, I'll show you. And then you can go back to just normal code that's always going to run one after another. Okay? Da-da-da. So this is going to be called an if-else statement, and it looks like this. It's pretty much the same as before from the first part. It's like if con, do you say your condition again? If the condition is true, give a colon. And then you give all the stuff that you want to have happen when it's true. All right, remember to tab over. Should automatically do it for you, though. True stuff. And then you unindent for a second, and you're like, okay, that's what happens if it's true. Else, you say else, and then a colon. Else, indent again. Then you give all the false stuff. Okay, that's how you do one thing or another. That's called an if-else statement. If the condition is true, it'll check it. It'll run all this stuff. Or if it's false, it'll run all this stuff. One or the other. Okay? And then after this whole thing is done, one side or the other side will just go on to whatever it's below it and unindented. Okay, let's show that. Let's do a condition on a different variable this time. I'll section off the program with a big long comment. Boop. And then we'll say, I don't know, let's be like y equals 15 this time. And we'll do like, if y is greater than 10, we'll do something, right? Or many things. Y is greater than 10. And then you can have as many lines as you want. I'll just have one this time. Unindent, say else, and I'll do something else. So if this is not true, right, what does that mean? Y must not be greater than 10. It must be less than or equal to. Y is not greater than 10. Right, no exclamation point for that one. Maybe. And then once it goes down one side or the other, it's going to go down this one, right? It's going to print Y is greater than 10. You unindent, and you're back to just normal code again. So always executed again. Da-da-da. So let's run this. Whee! So yes, if y is greater than 10, and it is, right, because y is 15, so it's true, and that means it will run this part, the true stuff, prints out y is greater than 10, and then, because it's picked a side to go down, it's done with the whole thing. Only is one side or the other. It's done with the whole thing now, and we go back to just the normal straight lines of code. Okay? If y was small, though, again, we'll make it 9 this time, I don't know, and run it. Now it's not greater than 10, right? Y is not greater than 10, so this is false. We'll jump to the else, right, because that's what gets run when it's false. We'll say that y is not greater than 10, and we've picked a side to go down again. That means the whole thing is done once we finish that side, and we're back to the rest of the code down here. Okay, see the difference? Does that make sense? Yeah. Yell at me if you have any questions about that stuff, but like that gives us the ability that we had in Scratch. Now we have it again, all right? So let's do some complicated conditions now. We'll make, there's something in between. It's called an if else statement, all right? So you have to say elif. Elif is short for else if at the same time together. So this is like when you have a bunch of conditions, and like sometimes you need a bunch of if else's. One very good example is like calculating grades. So like if, like this is the kind of checking that you would do like in Canvas, for example, when it's telling you your grade. It's like, is the grade greater than or equal to 90? If so, it's an A. Otherwise, if the grade is greater than or equal to 70, let's just pretend that's only A, C, or F. Then it gives back a C. Otherwise, else, it's an F. And imagine you can do the same thing for A, B, C, D, and F, right? So how would you check this in code? Like, given like a grade variable, you check first, like, is it greater than or equal to 90? Right? And you go down a branch. Like, if that's true, it's an A. If that's false, well, it's either a C or an F at this point. You see how you have another condition to check. So it's like, all right, maybe it's a C. So let's check if it's greater than or equal to 70, the grade. If that's true, then it's a C. Otherwise, we'll just pretend it's an F. All right, if it's false. So that's a great example. Like if the user types in your grade, and you can give them back one of those grades, like A, C, or F. Does that make sense? So there's a way to do that without this new elif thing, but it gets a little weird looking. But like, let's translate this to code, and then I'll show you the elif part. All right, it'll make things easier. But we can do this without this new thing. It's better the new way though. elif.py, I'll call this. And so like, let's code this in the way we know how with our if analysis. All right, let's ask the user for a grade. Be like, hey user, input, enter your grade. Enter your grade. And we'll put that into a grade variable, but we want to do number stuff with it, and that grade could have been a number with decimals, right? Because a lot of grades have decimals in them. So I'm going to convert it to a float, whatever the grade was, because it gives you back it as a string, always. So now we got it as a float, shove that into a grade variable, and now we can do these checks, right? A, C, or F. So the first thing we'll do is this first condition, check if the grade is greater than or equal to 90. Okay, so if grade is greater than or equal to 90, do something. Print A, right? Like that. And then else, do you see how the else part is all this down here? It's like, it's either the C or F. Now we have another check to do. That's a new thing to worry about. And I guess because we're doing floats, it could be 90.0 if we want to be pedantic about it. So yeah, if we're in the else case though, it's either could be C or F. There's more checks to do, right? We're not sure. We just know that it wasn't greater than or equal to 90 if we get to the else. So all right, it could be greater than or equal to 70 though. So let's check that. So let's check if it's a C. If grade is greater than or equal to 70.0, then all right, if that's true, it's a C. Otherwise, then it's definitely an F, right? We'll say. We'll imagine that you can only get an A, C, or F in this special class. All right? So that is going to be the translated form of this on the right. Does that make sense? How I got from there to there? So it's like you got an if else within an if else. Because like once you get to this else, right, you're not sure. Like it wasn't an A. What is it? We still need another check to figure out, like, break the tie. Like, was it a C or an F? So let's watch that work. Enter your grade. I don't know, 95. That's an A because it will be this part, right? It's like, all right, I went down a branch, and so I'm done with the whole big long outer if else. If I rerun it though, and I type like, I don't know, 75, then that's going to print just C, and I hope you see why. It's like, it's going to do one of these, exactly what that is drawing there. Like, all right, the grade was 75, so it's not greater than 90, so we're going to hit the else. And we're going to do this if else. We're going to run one of those bodies of those branches, we say, okay? And then, all right, is 75 greater than or equal to 70? It is, so we're going to pick the true part and skip over the false part. So that's why that will print just C there. Oops. And then finally, if I do like 55 or something, well, it's not greater than or equal to 90. 55. Then we try this one, right? compare 55 to 70. It's not greater than or equal to 70, and so we hit the else finally. And so that's F. Okay? Any questions about this code and why it looks like that? You need those inner checks and then else. All right. So there's an easier way actually, and it makes it easier. Like you can turn your code into something that essentially looks like that, which is like makes sense to me as a human, and it scales well when you're like doing checking for B's and D's as well. So that's called an elif, right? Elif makes these nested things. This is called nesting your if-elses, by the way. Like you're nesting it inside of another one, an if-else within an if-else. We can use this elif thing to make our life easier. I don't like, oh, well, let me get rid of the underline, sorry. In Python, yeah, what elif means, we're about to use that, put it in between ifs and elses. It stands for else if together. If you're coming from another language that uses else if spelled out, can't do that in Python. You have to say elif. All right, it's got to be elif. It's shortened. It's like an else and an if together all at once. So yeah, think of it as. But whenever you see it in code, read it as otherwise. And so here's how elif works. It's an if elif else statement. You say if, you give your condition. All right, your first condition to check. This is like condition 1, let's say. And then you give what do you want to have happen when if that condition is true. That's called the body of the if, right? So we'll call this body number 1. Okay? And then maybe like if condition 1 was false, you want to try some other condition. Otherwise, we're going to say elif. Elif and give some new condition. Cond2. All right? All right, let me just spell it out. Otherwise, if cond2 is true, do body 2. And then be done with it. And you can do as many conditions and as many elifs as you want. Like elif again, some condition number k, I don't know. If that's true, then all right, do body number k. And then finally, if you give up, like nothing's true, you can have one final else still at the very end. Be like, all right, that's your last body k plus 1. Yeah. So how this works is you kind of read it like, all right, if condition is 1, condition 1 is true, do body 1, and be done with the whole darn thing. Elif, read it as otherwise. Otherwise, if cond2 is true, then we're going to do body 2 and be done with the whole thing. And so that's kind of how this works. This is only tried. This condition is only ever tried. Only ever tried if cond1 fails. So you know that you didn't get cond1 because it would have run the body 1 and just been done with everything if you get to cond2. And so it's like, read it as otherwise. Otherwise, if this is true, do this one. It's like your second most popular thing to do or something. All the way down to this one. Otherwise, all right, if none of those ones above were true, try this one. If that's true, do this one. And be done with it. It's always just one body ever will only be run. And then otherwise, at the very end, else is still an otherwise, I guess. Only if every single condition is false do you get to the else. And then you run that one. That's like your fail-safe. Only if every condition is false do we ever get to there, right? And so you kind of read elif as otherwise. And so let me translate now the code that I just wrote into this, all right? It's going to look a little bit cleaner. You don't have to do you don't have to do any nesting at that point. It's going to be the same code. It works just the same, but it's going to use this elif idea. Alternatively, if elif else, we only need one elif, right? Let me copy and paste it, and I'll show you kind of why elif kind of means else if together, because I can squish it in this way. Okay, so here's the two pieces of code. I just copied it down to here. And so what I'll do is I'll be like, all right, if greater than or equal to 90, print A, that's perfect. I want to do that. Otherwise, elif, maybe it's greater than or equal to 70. Try that one. If that's true, print C. Otherwise, if that's not true, print F. I think that way's cleaner, honestly. Once you get used to it, like you don't have to indent as much. It's going to do the same thing, though. Does that kind of make sense? Both of those pieces of code are going to do the exact same thing. It's going to print A twice, or C twice, or F twice. They're equivalent pieces of code. This is using the elif now. All right? Greater than 90, print A. Otherwise, oh yeah, I do want to save. Like 95. It's going to be like, all right, do this one, and it's done with the whole thing. The second it runs its body, once it gets 1, it's done. It's like it just runs the first one that's true. That's what it does. 75, so it's going to skip the first one, right? This is false, and it's elif. Otherwise, try this one. Oh, that one's true for 75. Print C. Be done with it. And only if all of the conditions are false do you get to the last one. This is not true. This is not true. Otherwise, all right, finally, fail safe. We'll do this one. Okay? So that is if, else all together there. Any questions about that? And so I highly encourage you to take this program as I give it to you and do one for like a normal grade in a normal class with B's and D's as well. See if you can get it working both ways. You'll see how disgusting and indented it gets this way, and you'll learn to love it this way, I think. Okay? So, if we are happy, I would like to teach you a new thing in the turtle module. All right, let's talk about how to draw cool stuff with color and like to fill in our shapes, I think, as well. So, yeah, let's do that. So there's a way in the library, if you look into it, it's called dot pen color, that takes your turtle and like dips his tail into whatever color you care about. So like my best drawing of a turtle again. And he needs a tail, and like you can say turtle.pen color red to change his tail's color, like the color that he's going to draw with when he moves, to red. Put red ink on his tail. Yeah. And then if he goes forward, it'll make a red mark. And then you can change the color again, like set pen color back to blue. And then tell him to go forward from there, and then it'll start making blue marks. Won't that be fun? So let's do that. Let's just turtle.pen color. That's going to make some colorful lines. So I'll call this colored, sorry, as the name of the file, I will call this colored lines.py. Make this small. There we go. And so to do turtle stuff, we always import the turtle module, and then we're off to the races. I like to make my turtle look like a turtle, so I say turtle.shape, and then in as a string we give what we want him to look like, so please look like a turtle. And then I can do this game, turtle.pen color, whatever. Turtle.pen color red. And remember that strings in Python, they could be either single quotes or double quotes. Python doesn't care, as long as you're consistent. So now the pen color is red. If I move the turtle forward, he's going to make red marks. By 100. That'll be cool, so let's watch that work. Small. There's a red mark, and you can also always see like what is the color on his tail. It's like his outline. So shows what his pen color is right now. So by default it's black, and it didn't look any different, but now it does. And then let's like turn the corner, turtle.left, turn left by 90 degrees. So now he's sitting this way, right? Ready to go upwards, north. We can change his pen color to something else and go forward then, and it'll make like a blue mark. All right, if I do it that way. And now his outline is blue, and I drew a blue line. That's kind of nice, right? So that's just a new feature of the library, if you haven't read into that yet. I hope that makes enough sense. But you have options. You can make a very colorful name or something if you want. Your initials. So there's that. What else do I want to show you? So just like you can color your lines, you can actually fill in your shapes. Let me show that to you. Filling in your lines. So here's the trick. Just like there's a pen color, there's what's called a fill color as well. All right? If we set that and draw a shape in a special way, we can fill in the lines that we draw. Okay? So we're about to do this. All right? So you say turtle.fill color something. So that's your fill color. And then then you go and you start drawing a shape, and you wrap around that shape with these calls to the Python library turtle module. So you have to tell the turtle, hey, I'm about to start a shape, get ready to fill it in. That's essentially what we're doing. It's called turtle.beginFill and turtle.endFill. Okay? So like he doesn't know when he needs to start filling in things, so we're going to tell him, now is when I want you to remember, I'm about to close this shape off. I'm about to make a shape that I will eventually close off, fill in after I'm done. All right? So what you say is turtle.beginFill after you've set the fill color to whatever you want. Turtle.beginFill, then you draw your shape, like you draw, you make them go forward in all the ways to draw like a square or something. And then you say turtle.endFill, and the second you say endFill, he'll notice like, oh yeah, that was a shape you just closed off. I'll fill it in with whatever my fill color was, blue or green or whatever. Okay. So like every time you draw a shape, you have to wrap around, if you want it filled in at least, because we've made plenty of shapes that weren't filled in, right? You have options. So if you want it filled in, you have to wrap it around this begin fill and end fill. Okay, so let me show that to you. So that's the goal. And so if you say fill color green, and then begin fill, and you start doing some wobbly looking thing, and then you say end fill, the turtle will close it off and fill it in for you with whatever color you set. Okay, so let me show that to you. Let's take what we did, I guess. Like this is almost a square, why not? Let's keep it a square. I'll make a new file called filled shape. So you're getting a bunch of files today, .py. And I had before, because that's almost a square, right? So let's make a square once and for all. Turn the corner again, copy and paste this a few times. This will make a normal square, but like a colorful on the outline square. I don't need the final turn at the end. Here is a pretty little square with colored outlines, but let's also fill it in, okay? So what we'll do is we'll say, hey, turtle, here's a fill color for you. Get ready with this one. By default, it's black. So we want to change it to something else. We'll say turtle dot fill color green. So you can set this separately from the pen color. It's the outline versus the fill-in color. Okay. And then here's my square drawing stuff. I just have to wrap it around a begin fill and end fill to tell the turtle, like, I want this shape filled in, please. All right. So this is what I'll do. I'll say turtle.begin fill up here before I start drawing the shape. And that just tells the turtle nicely, hey, start filling. Start filling, please. And then after I've drawn my shape, I've closed it off, I get down to here, right? Then I say end fill, turtle.end fill. To say, I'm done. I'm done with my shape. I'm ready for you to fill it in with whatever the fill color was. Okay? So I run this with F5. Whee! You can see that his fill color is his body color as well. So like we made him actually look like a turtle now, kind of. And so the second this gets closed off, I paused it with my mouse right here. The second this gets closed off, he'll do the filling. So now we have a filled in green square with red and blue outlines. All right, I'm sure you could make something look fancier though. You draw like a forest of trees now, couldn't you? Like you fill in rectangles for like the trunks of a tree and fill in green triangles, like stack those to make it normal. Right? So that's begin and end fill, and also the pen color stuff. Any questions about any of that? Just like another feature of the library. Cool stuff. Yeah, so now I want to kind of like make a really cool shape. So we know how to draw squares, right? We know how to draw a few shapes. I want to show you something fun. I want to introduce a new library. It's called the random library, all right? And this gives back random numbers, usually. That's what we're going to use it for, at least. And so there's a random library in Python. You can search for it for the documentation, Python random, and read all the stuff. But we're just going to be using one function out of this library. At least right now, we're going to say random.randint 2 values, all right? And so we first have to, of course, import the library. We got to say import random before we can use random stuff. But this is going to make it really cool looking. Like, just think, like every video game you've ever played, like the enemies are made in a random spot. Like this will help you make fun things that are different every time, random things. So you call it like this, random.randint, random integer. Then you give 2 numbers, 1 and 10, and what it will do is it will like roll a 10-sided die or something, and it gives you back a random number between 1 and 10. So like every time you rerun this line, it's going to give you a different value back. It's random each time, all right? And then we'll shove that answer into n and use that to do something, all right? So I think my best example that I can give you is let's make some random squares, all right? Just think of it. Like what information do you need to draw a square? This is like a philosophical question. Like, how could you, like, here's a coordinate system. How could you specify, like, I would like you to draw, please, for me, like, in words, this exact square? What would you tell to somebody? Like, I want you to draw this exact square right there on that graph. How would you describe that to a human? That one. How would you, in words, what would you do? What does it mean to represent a square as an idea? That exact square.
Go to like this exact
Yeah, you need a coordinate. You need to pin it down for sure. That's actually one answer, just to give 4 coordinates, right? All the 4 corners of the square. That would describe the square. Do we all agree? You could also, there's a slightly easier way. You just need to pin one corner down and say that we're going to give the coordinates of the bottom left corner. And then you could also pass along the width and the height. See how you could also, that would also perfectly describe this exact square. You gave the bottom left corner coordinate and also the width and height. That's slightly less information, so we'll use that way. But yeah, the 4 corners would work as well. But yeah, you can represent any square, the idea of any square, with that information, right? The width and height and where its bottom left corner is, for example, right? So to randomly draw a square, we will randomly generate a bottom left coordinate and a width and a height, put them into variables, and like go there and draw it there, okay? So we'll pick a random starting point, of course, with our pen up so that we can warp there, and we'll go to like a starting coordinate. We'll pick like a random variable, starting x, right? Starting x, like a random number between negative 200 and positive 200. Like that's the starting coordinate for our, like, could be there, right? Starting x, and we got to do the same for starting y, right? Starting y. And I guess also because it's a square, like the width and height are equal, technically, so we only need one of those two. We'll pick a random number for the y coordinate as well, where it starts in its bottom left corner. And we'll go there, right? Go to wherever those variables take me. But that's how we'll do it. We'll make some random numbers, shove their answers into variables. And then we'll also need to like do a random size. So we'll pick a random size with another call to random.random, like pick a random size between 50 and 200. All right? And we'll shove that into a variable. I'll call it square side length. And like you can imagine, like every time you rerun your program, it will draw a completely different square somewhere else. Isn't that cool? Like maybe it randomly gives back 150 as the size of this current square. And then you like say turtle.go to these coordinates and start drawing a square by going forward, right, of that amount, whatever that was. Isn't that cool? Just use the variables, whatever's in them. Okay? And so that's going to be the goal. And then we'll fill it in with colors in just a second. But let's just get one random square started. Okay? So I'm going to need stuff like this. Let me copy this program maybe. And I'll make random squares dot pi. Actually, first, maybe I should just talk about the random library, just quickly. I'll call it random. You can't call your file if you're going to use the random library. It can't be called random.py because then it forgets where the library is. So I'll call it like randomness.py. So here's a quick example of the random library. It works like this. So just so that you have this at your disposal, you gotta say import random to use this. All right, let's do it without drawing right now. And then you say like, say this, n equals random.randint 110. And that will give you back a random number between 1 and 10, and it will be different every time, whatever is in it. So I run this program once, it gave me back 3. See that? If I run it again, it gives me back 9. If I run it again, now n is 6. It's just random each time. Okay, so that's going to be the goal there. So we're going to hook into when we draw some random squares now. So let's take all this, copy, new, and I'll call this random squares. I'll paste in all this because that's one square, right? So like this is a square of size 100 because I'm going forward by 100. I want to turn that into go forward by square side length by some random number. All right. And then also we started at 0, 0. We should do something else, right? So we'll fix this. All right. Let's see here. So let's generate these random numbers. Let's generate a random starting x coordinate for our square, our bottom left coordinate. Let's see. Section off the start. Now it's time to draw one thing, right? Starting x is this. Starting y is the same, right? Create a random y coordinate for our bottom left corner of our square. And then also let's create a random side length that's never negative, right? It's like a number could be small, could be big, between like say 50 units and 200 units. And we'll use these to draw the square, right? So if these two variables make up the coordinates of where the square should start, we have to go there first. All right, so let's go to, I'll get rid of that one. the first thing we have to do is go to the random starting point. So turtle.up so that we don't like warp there in a weird way. It's turtle.go to, right? Starting x, starting y, whatever's there, whatever random values they were, go there. Could be 5200, could be negative 50, negative 200, we don't know. Go there, and then now we're ready to make marks. And if this was going to be the bottom left coordinate, we're about to like go and make the bottom mark of a square first. Like we go to the spot, like do that one, then this one, then this one, then this one. We want to make sure we're facing to the right or east at the start as well. So like just in case we aren't right now, let's go around starting point and face east. That's a call to dot set heading. Okay, so that set heading is 0, 0 for east, for to the right, 0 degrees. And then we'll keep the fill call for now. We'll get rid of the pen colors. Let me just condense all this. So this is going to draw a single square, and it will fill it in with whatever our fill color is. All right, so now we're at the bottom left coordinate. But when we get there, we're going to draw a 100 size square right now. You see, because I'm going forward by 100. I want to draw a square with a random side length. So I'm going to take whatever was placed into here, whatever random value was placed into here, and use that to mean how far I go forward. Okay, go forward by square side length. Could have been 50, could have been 200, could have been 127. It does not matter. All right, it's random. But all those things together now will make a random green filled square because that's what the color is right now. All right, and so here it is. Remember to import turtle. I also need to import random because I'm using random stuff. But after both of those, that should do it all. Okay. And so I get a square way over there. Hard to see. And that was random. Right? I went to a random spot. Apparently my starting x was positive and my starting y was positive. I went there. And then I faced right and I started drawing. And I had a big side length. It's bigger than 100 or something. So pretty big square. Let's do it this way. Let me try and pause it as it starts up. There. Okay. So do you see how now we started down there? We faced right. So that means our random starting x was negative and our random starting y was also negative. Cool. Now we're going on our first line. Let's see how big our square is going to be. Okay, that's like a middle of the road size, maybe like 100-ish. It was random though. And then it fills it in. It's different. Isn't that cool? We'll do this one. Okay, that's another one there. Does this make sense why this code is going to work like that? It's going to pick these random numbers, and we're going to use those random numbers to draw our square. Like the length has to do with how far we go forward, just like go forward by that random amount. And where we start has to do with like our current coordinates at the beginning. We'll just go there. So that was a big square. There's a little baby square. Question? Yes, there's another way to do it. You're going to need a new idea. You're going to need the equivalent of arrays in Python. Go to a random index of that array. That's one way to do it. But we don't have that knowledge just yet. But yeah, that's a great question. And I'll show us how to do that. Make a random color soon. Right? But not today. It's called a list. Yeah. Yeah. So look into that if you would like. But yeah, that's one way to do it for sure. Dun, dun, dun. So let's make let's see. Let's ask the user which color they want. That's like, let's not make that random at least. Let's ask the user, hey, which color would you like to use for this random square? Instead of setting the fill color always to green, we can ask the user. So let's do that. We'll say, hey user, tell me what the fill color should be for this random square. Input, enter the color, colon space or whatever, and I'll shove that into a variable called color to use. Maybe they did type green, I'm not sure. But the fill color needs to be set to some string, and so input does give me back a string already. That's perfect. Doesn't have to be a number or anything. And it's like whatever thing they gave me, set the fill color to that. Does that make sense? And so that's now controlling what the fill color should be. I can make it red, stopping the color red, and then it goes and makes a random red square. So it's just setting that fill color at the very start like that. It'll work. So that's this code, and enter the color. I don't know. A lot of these colors work. Just like try them out. Some of them work. A lot of them exist in Python. It knows about most colors in the rainbow. And So there's a pink square, pink random square. All right. So that's set in that fill color. Does that still make sense? We're asking the user for their favorite color or whatever. And I think the last thing I want to do is let's draw 5 squares total, 5 random squares total. All right. We do not know how to loop in Python yet, so the way that we can do it is like here is code right here that draws 1 random square. Right? It picks all these random numbers to go and draw that square, and it goes there and does it. If I just duplicate this code 5 times, I'll get 5 random squares in different spots, right? Because it's going to be new random numbers shoved into those variables each time. So let's do it that way. And I'll just copy and paste this code 5 times. So there's 1, 2, 3, 4, it's a little ugly. 5, but it'll work. And so let's make, so I've just done it a bunch of times there. And let's run it, and I'll say blue or something. And it's going to do it 5 times, right? It's going to go to different places, right? Because this starting x is a different starting x than the first one. It's calling random again. It's making new random numbers, and so there might even be overlap. Isn't that cool? You can make some really cool abstract art if you like did 100 of these or something. And then you also figure out how to get the colors random. Try to figure it out before next time, maybe. But yeah, that's just a fun little idea. And our color, it's a color I haven't done yet, orange. Big square right there. A little square inside of it completely. This is random. This is just random coordinates every time. We know how to draw a square at those places. So like that's a beautiful abstract art that you can hang on the wall, and you get a turtle in the picture as well. Lovely. Yeah. Does that make sense? Any questions about that? Yeah. Yeah, it's on the library documentation page. So if you search for Python turtle, you can see what it can be. It's shape. Shape. You can't make it anything, I don't think. Let's see. Yeah, you get the following options: arrow, turtle, circle, square, triangle, or classic. Yeah, try them out. We'll see which ones those are. I don't remember which one's the default either. Maybe it's like an arrow. It looks like an arrow, but it could be the classic one. I'm not sure. Classic arrow versus modern arrow. But yeah, that's fun, cool stuff that we have access to now. All right, so it's random squares. You can draw 50 of them if you duplicated that code 50 times. Okay, so yeah, are we good to move on? I have one last thing, and that's just to tell you about your programming assignment, which is going to have to do with this example. So I'm going to give you this code. Hopefully you remember how to get to it, right? The code from ClassLink. I'll give it to you after the lecture, and you will go there, and this is going to lead into, very nicely, your programming assignment. So let's see. Dun, dun, dun. Years ago, there was a weird, there's a very weird YouTube video. It's like some sort of absurdist comedy sketch or something. And that's what I'm drawing from here. So what I want you to do in your programming assignment is, it's a very weird video. If you want to go look it up, it has to do with green not being a creative color. I don't know if you've heard of that one. But it's a fun old YouTube video. And there's a whole song to it, I think. But what I'd like you to do, because I gave you an example program where we drew a bunch of random squares of, in random sizes and locations, using a color that we got from the user, I'd like you to draw a bunch of triangles filled with a color that you got from the user, okay? So here's your goal. But there's one caveat. Green is not a creative color, so you have to, if the user asks for green, you have to disobey them, right? So here's the setup. So I want you to make a Python program that kind of copies what I did, use turtle and random to draw 10 triangles of a random size and location. They can be the normal equal lateral triangles that I already showed you how to do, but take my square code, turn it into triangle code, and make 10 of them. Okay, so that's that one. And then I want your program to ask the user which color they want to use as the fill color. And normally, if they want red, do 10 random red triangles. If they want blue, do 10 random blue triangles. If they ask for green, though, use that as the fill color unless they ask for green. If they ask for green, then you have to disobey the user. You cannot draw green triangles. Okay? You could, but you'd have to learn about loops. I would accept it, though, if you wanted to read ahead. Learn ahead. But, if you don't want to do that, I'm forcing you to use an if statement. That's the whole goal here, right? I just taught you if statements. I'm forcing you to use one. If they say green, then maybe you can just like, all right, I'm going to make it blue. Like set it to something else if they say green. Like that's an easy way to get around this idea, okay? But normally obey them. Like if they want red, give them red triangles. If they want green, give them something other than green, okay? Change it to be something else, or yeah, ask them again if you want to learn about looping, because they might also type green next the second time. Like you have to keep going, so that would require a loop, right? So yeah, you can use a lot of my stuff. Feel free to look into this absurdist video, but that's the idea. I'm forcing you to use an if statement and the turtle module and the random stuff. Okay, so yeah, all that I want from you is a video as usual showing me that, like showing your code running. So it's like type red as an example, make it do the red one. Type green so I can see you disobeying the user, not drawing green triangles. Yeah, just show me your code, explain it to me. Doesn't have to be very long. Okay, so yeah, I think that's all that I wanted, and that will be due on Halloween for most of us. So you got a couple weeks to do it. Are there any questions about that? That's going to be your example program. You've got to disobey the user if they ask for green, though.